My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 211. In this lecture, I will continue my discussion on line, plane and hyperplane. I can say it is continuation of my previous lecture, that is lecture number 210. In lecture number 210, I derived this particular equation pi n, which is equal to W naught plus W transpose x equal to 0. What it is? This is the equation of the plane. I can say this is equation of if it is n dimensional, if it is n dimensional, I can say this is equation of hyperplane, isn't it? If it is 3 dimensions, I can say if it is 3D, this is equation of plane, isn't it? It is equation of plane in the case of 3D. If it is in 2D, it is equation of line. All these things we discussed in my previous lecture, that is lecture number 210. Now the immediate question I have here is, all this looks beautiful, but this W naught, just see this W naught, but this W naught is still hanging around here. What does it exactly mean? So let's understand what W naught actually is. So let's go to a two-dimensional geometry, because that's where we can easily understand things and we can take whatever we learned from 2D into higher dimensional spaces, isn't it? So we will always learn ideas in 2D and take it in 2D to n dimensional spaces. That's what we were discussing in last lecture also, that is in lecture number 210. Just learn things in 2D and extend them to into ND or n dimensional spaces using which concepts? Using linear algebra, isn't it? That's is the power of linear algebra. When I first learned about it, I could not stop thinking about how beautiful and how powerful it is. Now let's say I have two axes, x1 and x2. Let me say this axis is x1 axis, this axis is x2 axis. I have two axes. I have a line like this. Let me say I have a line like this. Let me assume this line is y equal to mx plus c, isn't it? What is my c? This is my c. This is y-intercept c, isn't it? My equation of the line, this is my, let's say y equal to mx plus c, x1 equal to x and x2 equal to, here what is your x1 in the place of x-axis, I am writing x1, in the place of y-axis I am writing x2. That's what we were doing from past few lectures. What is m? M is nothing but slope. In the case of y equal to mx plus c, what is my m? M is slope. M is nothing but slope of your line, m is nothing but slope of our line, and c is nothing but y-intercept. It is simple equation which we learned in our primary classes. My c is called y-intercept and my m is nothing but slope of the line. So if I write general equation of the line, general equation of 2D line, how can I write general equation of 2D line, which we discussed in my previous lecture? Just let me write general. Can I write like this? General equation. General equation of line. I can say it's in 2D line. Let me say in 2 dimension I have line. How can I write W1 x1 plus W2 x2 plus W naught equal to 0, isn't it? Let me just rearrange the terms here. I can write it as, how can I write this one? Your x2 can be written as, if I rearrange this one, how can I write x2 equal to minus W0 by W2 minus W1 by W2 into x1. It's simple mathematics, isn't it? Just compare this with y equal to mx plus c. I can write y equal to c plus mx. I can write. Therefore, what is what is c here? This is nothing but, what is the c? Here c is nothing but minus W0 by W2, isn't it? If a line is passing through the origin, what happens to c? If it passing through the origin, c becomes 0. Just see, y equal to mx plus c. If it passes through the origin, means I must keep x equal 0, y equal 0, 0 equal to c plus m into 0, 0. Your c will become 0, isn't it? If c equal to 0, what happens to this particular term? Minus w, if it passes through the origin, minus w naught by w2 will be 0, which is equal to w naught equal 0. Even in straightforward manner, we can keep x1 equal 0 and x2 equal 0, so that what will you get? You will get w naught equal 0. If I have line passing through the origin, you cannot have c, isn't it? What its y-intercept? If it passing through the 0, what its y-intercept? Your y-intercept c is 0. If it is passing through the origin, then your c equal to 0. In the case of y equal to mx plus c, if it passes through the origin, your c becomes 0, and if c has to be 0, if c is 0, then I can say w naught is also equal 0. You need not do these many things. Just substitute x1 equal 0, x2 equal 0, then w naught, you will get w naught equal 0. If c equal 0, that implies in my general form, or in my general notation, or in general equation of a line, that implies your w naught equal to 0. Therefore, if your line passes through the origin, what happens? Your w1 x1 plus w2 x2 equal 0 as w naught equal 0. It is simple mathematics. Maybe I think I am making it is so complicated, but it is not that complicated. It is simple and straightforward. Let me write it as, in the case of 2D, if it passes through the origin, how can I write? w1 x1 plus w2 x2 equal to 0. W naught will be 0 as it passes through the origin. If it is 3D, in the case of 3D, what happens? w1 x1 plus w2 x2 plus w3 x3 equal to 0. This is 3D case, isn't it? In 3D, it is a plane. I can say it is a plane. In the case of 3D, it is a plane. In the case of 2D, it's a line, which we discussed in last class. In the case of n dimensions, nd, how can I write? w1 x1 plus w2 x2 plus so on wn xn equal to 0. I can say it's a plane, which is nothing but a plane, isn't it? I can write, which is, if this is, I can write w transpose x equal to 0. Why? Because there is w transpose x plus this is very concise way of writing equation of the plane. W transpose x equal to 0. This plus b will not be there as it is passing through the origin. This is, I can say, equation of the plane. Equation of plane in 3 dimensions. If it is in n dimensional, it is equation of hyperplane passing through the origin. If it is in 2 dimension, it's the equation of the line. Equation of plane, of course, this plane is passing through the origin. This is the equation of the plane passing through the origin. If it is not passing through the origin, then equation of the plane will be w transpose x plus w naught equal to 0. This is not passing through the origin. This is the equation of the plane not passing through the origin. If it is passing through the origin, then I can say, if it is passing through the origin, your w naught will not be there. You can write w transpose x equal to 0. Such an elegant term using the concept of transpose. I can write, I am using in this form, I am using transpose, isn't it? We discussed in previous class such an elegant term using the concept of transpose, and using the concept of matrix vector multiplication. Here I have transpose and I have vector multiplication, isn't it? We wrote the equation of any dimensional hyperplane within a very, very concise, very, very elegant form. Of course, you have to add W naught term if it is not passing through the origin. This is the term you must keep if it is not passing through the origin. Now let's understand the equation of a plane in a new way using slightly different geometric interpretation. So let's assume, I hope, a plane pi. How we are representing this one? It is represented by pi. It is an n-dimensional plane, and this plane passes through origin. If it is passes through origin, how can I write? In the case of n-dimensional, I can write hyperplane. I can write this as pi n W transpose x equal to 0. I am not keeping B as it is passing through the origin, where W is nothing but a column vector. Here you must understand, W is a column vector. W is nothing but a column vector. I can write W equal to W1, W2, so on. I can write Wn. This is a column vector, and X is also a column vector. I can write X as x1, x2, so on. I can say xn. Here W and X are column vectors. Now, if this is the equation of the plane, how can I write? That is W transpose x equal 0. My pi n is W transpose x equal to 0. Let us assume W and X are two vectors. We know that W dot X, we already discussed this dot product, which is equal to W transpose X. This dot product can be written as W transpose X. According to the definition of dot product, I can write norm W into, I can say, norm X cos theta. Can I write something like that? Let me say this is equation 1. Theta is the angle between W and X. Here, instead of looking W and X as a part of an equation, I am just looking at W and X as two vectors. This is the beauty of linear algebra. So W is just I can think of it as n-dimensional point. So X is an n-dimensional point. So these are 2 points. If W and X are 2 points in an n-dimensional space, let's assume this W and this X, this is the angle between. I can say this theta is angle between. I can say theta is angle between W and X. Theta is angle. It's the angle between W and X, isn't it? It's an angle between W and X. If W is perpendicular to X, what happens? If W is perpendicular to X, what does it mean? Your W transpose X is equal to 0. Why? Because cos 90 W transpose X equal 0. That means if that implies theta equal to 90 degrees, isn't it? If theta is an angle between W and X, I can say cos 90 is 0. Therefore, W transpose X will be 0. With this, let's understand a different way of interpreting this equation. This equation, let me say like this. Just for simplicity, I will draw a line instead of drawing a plane. Just let me say, instead of drawing a planes, let me draw a line like this. This is the case where the equation passed through the origin. If it passed through the origin, you cannot have W naught, isn't it? Let me say, I will draw a line. This is the draw instead of drawing a plane, because this is easy to interpret. As I told you, if you are able to understand things in two dimensions, you can extend this to 3 dimensions and even to n dimensions, and easy to understand. Let me consider this line, isn't it? Two dimensional space on which I am drawing line. Drawing a line is much easier. Let's say this is the origin. Let's say this particular line passes through the origin. Where can I write? This is, let me assume this is my origin. It is passing through the origin. This plane passes through the origin. Let's assume this is my origin. Let's assume this is any point. This is any point x1 on this particular plane. Here it's, I can say x1 is a vector, isn't it? Now we know that w is perpendicular. W is perpendicular. So let's assume w is a line. W is like this. Perpendicular means it must make 90 degrees, isn't it? Let me say like this. This is my w, isn't it? W is like this. W is a vector like this, which is perpendicular to plane pi. I will connect all these dots. Please bear with me. Now, if w is a vector which is perpendicular to your plane pi, what is my plane pi? This is plane pi. Let's assume w is a vector which is perpendicular to your plane pi, passing through the origin. Just for simplicity, now let's assume x1 is a vector. Here x1 is a vector, your w is also vector. x1 is a vector. I can say it's a vector. Since these two vectors w and x1 are perpendicular, these two vectors x1 and w are perpendicular, I can write w dot x1 equal to 0. So for any point on this plane, I can say, so for any point on this plane pi, if w is perpendicular to this plane, then I can write w dot x1 equal to 0. That x1 can be any point, and that's what we are calling equation of the plane. I can say your pi n is w transpose x equal to 0, isn't it? Instead of this x, if I replace any point on the plane, then my w transpose x equal to 0. If w is perpendicular to my plane, then if w, I can say, if w is perpendicular to pi, then if w is perpendicular to pi, then w dot xi equal to 0 for all xi, isn't it? Which belongs to this, for all xi, which belongs to my plane pi. For all xi belongs to pi. Take any point. Once if w is perpendicular to pi, w dot xi equals 0 for all xi belongs to pi. It is always important to read equation in English. One way to interpret this equation is w transpose x equal to 0. Is that you have a plane pi? This plane pi is passing through the origin. As I told you, it's w transpose x equal to 0, isn't it? It is simple and straightforward, isn't it? Because if you observe carefully, this this is what w is. It is very simple and elegant interpretation of w, because till now we did not explain what w is geometrically. What w means geometrically is nothing but it is a vector which is perpendicular to plane pi at the origin. There is something like unit vector. I can say unit vector is denoted by w cap, which is defined as w by norm w. Just you must divide with its magnitude. So instead of w, if I have unit vector w cap, even I can write w cap dot xi equal to 0 for all xi belongs to this particular plane pi. Oftentimes the plane pi is represented by vector w cap, that's unit vector. It is represented by unit vector which is perpendicular to plane. For simplicity, we often assume that our plane passes through origin. Just for generality, let's assume my line does not through. If it is not passes through the origin, just you must keep that constant, isn't it? For simplicity, I am assuming, so that the equation, for simplicity, I am assuming this particular plane passes through the origin. If it is not passing through the origin, just I must write W transpose X plus W naught equal 0. So I am avoiding W naught just for simplicity. That's why I am writing W transpose X equal 0. Let's assume all the planes passing through the origin unless I specifically say otherwise. So geometric interpretation of your W is nothing but it's a vector which is perpendicular to your plane. So in 3D, if this was your plane, just let me write, if it is 3D, what happens, just let me assume, if it is 3D, let me say this is plane. This is plane, isn't it? Let me say this is origin, isn't it? Where can I find? Your W must be perpendicular to this plane, isn't it? That's what it says. In 3D, if this was your plane, I just draw it for simplicity. If this was its origin, your W is a vector like this, which is perpendicular to all the points in the plane. Just go through this lecture once. If you have any difficulty, just keep a comment so that we will try to understand. Thank you very much.